Now, it was a bit of a pain, all that guesswork trying to find the ideal payment that perfectly paid off that balance within the 12 months. Wouldn't it be nice to make a computer do all that work for us? Well, that's what we're going to do. You're going to use Microbits, which is a coding block code language by Microsoft, and we're going to make the computer work to our advantage. So go to makecode.microbit.org. And it should automatically have you signed in with your Microsoft 365 account. You're going to click on New Project, and you can name that Finding the Monthly Payment, or My Monthly Payment, something like that. We're not going to use this forever block, so we're going to just drag that block until it turns into a garbage can. Bye-bye block. Okay, we'll keep the OnStart block. These are some basic menus that have types of code blocks that we can use. And the first thing we're going to do is invent some variables that will be useful to us. So we're going to click on Variables, Make a Variable, and a variable is just like a container that holds a value, and we can give our containers names, kind of like masking tape, putting Tupperware in the fridge. We're going to make a container for balance, this balance variable, and that you can see creates set and change blocks. We can set the balance value and change the balance value. And you can click that set balance, and you can see that on the start of our code, we could set the balance to be 600, for example. So let's make all our variables that we're going to need so far. We're going to make an interest rate. I'm using an underscore to keep it all as one word. I'm going to make a monthly interest variable, and I'm going to make a payment variable. Okay. A nice trick is you can right-click on a block and duplicate it, and you can use this drop-down to change the variable that you are setting. So on the start of our code, let's set our interest rate, and I'm going to use it as a decimal here, 0.21, just so we don't need to divide it by 100 when we want to use it in a calculation. Let's duplicate it again, and we will set our payment amount to our first payment guess, and let's just go with something we know is too high, 60. So these are going to be set when our code begins to run, and from there what we want to do is kind of loop through those monthly payments of $60 and add on 1 month's interest at 21% annually. So we are going to use a loop, and the type of loop we're going to use is a repeat loop, where we can drag that right under our variable introduction there, and I'm going to set this to 12 so that it loops 12 times through, and then we'll see what the balance would be at the end. So the first thing we want to do is calculate the monthly interest. So I'm going to go back to variables, and I want to set my monthly interest. Now the monthly interest, I need to take my balance, whatever it is at for that month, and multiply it by 21%, and then divide that by 12 to get 1 month's interest and not the full year. So we're going to need to do some math. So we're going to click on the math menu, and I'm going to grab the multiplication. I'm just going to put it down here for now, and I'm going to go back to my variables, and instead of typing like 600 for my initial balance here, I'm going to select the balance variable so that it will use whatever its value is for that month, rather than always only referencing the first value. So I'm going to take the balance, and I'm going to multiply it by my interest rate. So variables, whatever my interest rate is, that's what it's going to multiply by. But then I need to divide this by 12. So I'm going to go back to math. I'm going to find my divide block. I'm going to take all of this, and I'm going to put that as my first thing, and I'm going to divide that by 12. And then I'm going to click it here and drag it here. So now it's setting my monthly interest variable to the balance times the interest rate divided by 12. Now it can be a little cumbersome working with math blocks, I find. So another approach, if you wanted another way to do this, click on the JavaScript toggle if you're comfortable with inline coding. You can see it right now, it says monthly interest equals 0. Any blocks that were grayed out don't show up in JavaScript, but I could type what I want to do, and it helps me type. It auto-completes my sentences. So monthly interest is I just start typing balance, and it gives me the option of all the variables and things it might have. So balance times is that little asterisk, shift 8, times, I need interest rate, times the interest rate divided by 12. And if I go back to my blocks, look at that. It made that calculation block the same as the one I had down here. So I'll just drag this one over to the trash. Very nice. Now that we've got our month's interest, we need to add that on to our balance and subtract from our balance our payment of $60. So we're going to set block here, our balance to equal, and in this case, go back to math here. So let's first take care of adding on the interest. I'm going to take this addition block, and I'm going to use balance in its own assignment here. I'm going to set balance to be whatever the balance is. Back there, balance plus, I need my interest, monthly interest variable. So balance plus monthly interest. And then I'm going to need to subtract. So take my subtraction block, drag this into the first argument. So it's going to take the balance plus the monthly interest minus, I need my payment block. Payment variable. So the new balance will be whatever the old one was plus the monthly interest charged to me minus my payment. And it's going to loop through this, calculating the interest, adding it on, but subtracting 60, add on the interest, subtract 60, 12 times. And what I want to know is what do I owe by the end of these 12 months? So how will I display the remaining balance? If you click on Basic, there's a first block called Show Number, and this will show, we'll put it outside of the repeat cycle here. It will show on the LEDs. You can see right now it's showing 0, because that's what it says to show. But I want it to show balance. So I'm going to drag the balance variable right there. So let's click on the Start button, or it'll do automatically here, and it tells me negative $54.64. It's a negative. That means if I paid $60 12 times and it kept subtracting that from my original balance, I'm going to end up overpaying my debt and ending up with a negative balance. So 60 was too high. If I tried something less, like say $50, you can click on this retry button here, or refresh. $77.61, and if it went by too quickly, just press refresh again. So that leaves me with a positive balance, which means I haven't subtracted enough to get down to 0. So you could play with this and try to come up with the ideal monthly payment and get closer and closer, but this isn't much better than our spreadsheet so far. The real beauty of computers is when you make them do the grunt work for you. So the next step, to make our code awesomer, we want to make the computer try different payment amounts until it gets to one that is perfect. And we're going to put 60 back here. And this time, I'm going to just get rid of this show number balance, put it aside for now. What I want to do is I want to go down from 60 until it arrives at a payment that gets as close to 0 as possible. So I'm going to put another type of a loop here. I'm going to take a while loop, and I basically want to keep decreasing my payment amount and trying out my 12 payments while the balance is greater than 0, or at least far enough away from 0. Now, it's tricky to do here, but I want this to kind of go around my repeat loop. So if you can kind of, with your mouse, get it until it makes a gray wrench around the repeat loop. There it goes, swallows up the repeat loop. So the condition that we want to check for before looping again, we want to check, is the balance close enough to 0 or is it still too far off? Now it may be the case, because we're rounding to the nearest penny, that we overshoot slightly by a few cents and end up with a negative balance, but that might still be the closest that we can get, and we want to jump ship and accept that payment if that's the case. So first, in our logic, we can use this comparison operator, and you can use either one of these because we're going to change that drop down in a second. Drag that little, I'm not sure, diamond edged thing into the condition for the while loop, and we want to check while, and in math we're going to use what's called the absolute value of our balance. The absolute value means just consider the positive of the number, whether or not it's negative. So if it was negative 2 cents or positive 2 cents, doesn't matter, we're going to just think of that as the overall size of the number is 2 cents. And we want to check, is the absolute value of the balance still greater than? So we want basically to loop while the balance is, we'll do greater than or equal to 10 cents. So it's basically only going to check again if the absolute balance is greater than 10 cents. But the second it's within 10 cents, this condition will fail and it will exit the loop. So it's going to check 12 months of payments, and then before checking again, it will see, is that balance within 10 cents? Problem though, we haven't done anything to our balance yet, or to our payment. We don't want to check the same payment over and over again. So just before we run those 12 months of payments again, we are going to change, put this just above the repeat loop, we're going to change our payment by negative 0.01 cent. We're going to go down by 1 penny. But we've also been messing up the balance. We've been subtracting our payment from it repeatedly, and so it's left off at whatever it is left off with after 12 payments. So we first want to reset that before doing a fresh check. So we will set the balance back to our original balance of 600. So it's going to go down by a penny in the payment, reset the balance to 600, and then try 12 months of payments again. Now at the end of this, it's going to exit its while loop as soon as a payment results in a pretty much zero balance after 12 months. And we're not so much interested in showing the balance, because we know it's within 10 cents. What we are interested in is, what is that payment? So we're going to show the payment. And you can run your code, and you can see that it's 55 cents, or $50.87. And it is really fast. It was going down by a penny from 60 in a blink of an eye. Like, what if we started this at like 200? It's still going to go down. Let's run it. Took it no time at all. The computer doesn't care. Look at that. It just tried a ton of payment amounts, calculating 12 months of payments in a blink. The power of code. Beauty.